So hello and welcome back. So in this video we are doing another example here that says Cheppy, whatever that I've never heard of it of any name Cheppy, but Cheppy is an ecologist who studies the change in the narwhal population of the Arctic Sea over time. So she observed that the population loses 5.6% of its size every 2.8 months. So loses 5.6% of its size every 2.8 months. So the population of the narwhals can be modeled by a function n, which depends on the amount of time t in months. So here you have months, again here you have months, so you're good to go. Now when Cheppy began the study, she observed that there were 89,000 narwhals in the Arctic Ocean. Write a function that models the population of the narwhals t months since the beginning of Cheppy's study. Okay, so basically again you have two ways of solving this problem, without the table and with the table. Without the table it's easy. You know that it's a basically you know that it's a exponential function, and since that is the case, you have basically the general form of an exponential function is f of x is equal to a times r raised to the power x. A is your initial value, r is your common ratio, and x is your variable. Now what happens here is that you have a function n which depends on time, so I write this as n of t, and it's again a times r raised to the power t. And what is my a here? A is basically the beginning. In the beginning, what was the population of narwhals when Cheppy began the study? It was 89,000. So basically you write this as n of t is equal to 89,000 times r, which you get it from here. So losing 5.6% of its time every 2.8 months. Now just for now you can forget about the every 2.8 months part and just focus on losing 5.6% of its size. So losing 5.6%, and here I want to write a function that models the population of the narwhals t months since the beginning of Cheppy's study. So that basically means that the function is modeling the population of the narwhals. The population of the narwhals means that the narwhals that are left after t months. So losing 5.6% means that you are left with, or you could just use the 5.6%. You could simply use the 5.6% because that's when you take the 5.6%. No, you cannot use the 5.6%. So I know that the population loses 5.6% of its size, but so let me write it down here. So the population loses 5.6% of its size. This I know. What I want is the population the population left as a result of this, as a result of this happening, as a result of 5.6% of the population being lost, what is the population left? So basically, if I take my population as x, I am losing 5.6% of this x. So I have to subtract from this x 5.6% of x. So it's x times 5.6 divided by 100. And so that becomes x times 1 minus 5.6 divided by 100. I'm taking an x out, and this is not multiplication, this is 5.6. So I can write this as 100 by 100, so x times 100 by 100 minus 5.6 divided by 100. So it becomes around 24.4. So 24.4 divided by 100 x, and this is 100 minus 5.6 is 24.4, and so this is 24.4 divided by 100. You move this decimal point two places to the left, so it becomes 0.244. So 0.244 times x. So if I multiply 0.244 by any amount, that basically means that what I'm calculating here is the amount left from x as a result of 5.6% of x being lost. That's basically what this expression means. Let me see, is it right? So x minus x times 5.6% and 1 minus 5.6%. So you are left with 100 by 100, so it's 20. No, I've made a mistake here, I'm sorry. This is not right. Sorry. So I'm sorry, 100 minus 5.6% is 94.4 divided by 100. And again, you can move this decimal point 2 units 2 places to the left because you're divided by 100. So it becomes 0.944 times x. So basically, if I multiply this number 0.944 by any amount, by any variable x, that means I have lost 5.6% of x, and as a result of that, this is the remaining part of x as a result of 5.6% of x having been lost. So that's basically what happens here. So we were talking about this part here. Losing 5.6%, and that was basically my R here. So your R is basically 0.944. 0.944, and normally I would simply write this, raise this to the tenth power, but here we said that it is, its size, it loses 5.6% of its size every 2.8 months. So if I simply write, So it's every 2.8 months. So if I write simply 0.944 raised to the teeth power, this 0.944 is being multiplied by this population every month. But as stated here, it happens every 2.8 months, not every month. So I have to divide this by 2.8. I have to divide this by 2.8. And so as a result of that, when t is equal to 2.8, that means after 2.8 months, then this fraction becomes 1, because it is 2.8 divided by 2.8. So 2.8 divided by 2.8 is 1, so the fraction becomes 1. And then once it becomes 1, then it's actually 0.944 raised to the first power, which is 0.944. And 0.944 is multiplied by this population, and then this population, as a result of that multiplication, loses 5.6% of its size, and then this much again is remaining, and then the same thing happens over and over again. So basically the equation that we were looking for is, I suppose, this thing over here, 89,000 times 0.944 raised to the t over 2.8. I hope you've understood my explanation. If not, I guess you have gotten that. I guess you got that. If not, you can simply ask questions. Okay, so we have some more problems here, but they're not, unfortunately, not too many are left. But so I'll see you in the next video. Thank you.